Hi, Satyen. Satyen Bahai, can you hear me? Ah. Non, il a fait direct. Ouais. Mm-hmm. So he can hear me, or Satyen, can you hear me?
Oh, yes, Bhai, good afternoon from India.
Excellent.
It's good to see you, but earlier presentation I was unable to listen properly, but I can hear you well. What about my voice coming to you?
Yeah, very well. So we're going to check now on your presentation. Il va faire directement sur son truc. Okay. So now can you share your presentation?
Okay, let me try whether can happen.
So pick up your PowerPoint.
Yeah, is it coming?
Yeah, go to the first page, first slide.
Let me just see whether I can scroll it from here.
Yeah.
So that this is the first one. Can you see the first one with
Correct.
the title?
Yeah. Yes, I see it. So can you blow it full screen?
Yeah, I think it. Yeah. Full screen. Yes. Let me just.
There you are.
Is it okay now?
Excellent. Let me introduce you in few words. Right, so we have with us a very famous gentleman from India, that's Dr. Satyen Gupta, the man in charge of the regulator in India called TRA, to introduce IPv6 in India. And in the meantime, he runs also the blockchain for productivity enterprise. And he is quite successful with the deployment of IPv6 because they have reached about 400 million IPv6 users, which is about 60%, 64%. And he is the first one to combine IPv6 and blockchain according to the lines that we have been discussing today. So we have him with us for the next 30 minutes. I know when I give you the word, you won't stop speaking. So I'll come in between to tell you, please speed up to be on time with us. So Satyen, the slide is yours.
Oh, thank you, Latif Bhai. Good afternoon, everyone. First of all, I really want to wish you all a very happy Holi. What is the festival of colors in India today? I've just come back from my party in the club with the family. Actually, that is why I'm not properly dressed for a event like this. But I hope you will pardon me for that. And I'm really thankful to the organizer from Morocco and especially from Latif Bhai to give me this opportunity actually to make a presentation on a topic which I'm working. Actually, it is a combination of IPv6 and blockchain, which can lead us what we call a decentralized, secured digital public infrastructure. So I've used some words from my own side. Basically, what I want to cover here in half an hour is that how we have done with the policy as well as the implementation side of IPv6 in last actually 20 years now, and how we are trying to actually converge IPv6 and blockchain so that they complement each other and finally help us to have what we like to call a secured public internet, which is totally decentralized actually. And we'll see how both the technologies, if you call them, will help each other actually. So the agenda is of course big, but I'll not be going through all my slides. This first one everyone knows actually. IPv6, the new internet and what it brings to the table. Not only the massive address space, but also it brings ease of use, plug and play, ensures end-to-end transparency, improved security features, mobility capabilities, and now with actually working with blockchain, AI and IoT together, it actually brings some very, very interesting killer applications actually. So IPv6 basic perspectives, of course, from user side, actually what user want, we all are user. We know we want a end-to-end connectivity at negligible cost. In India, they want it free actually. The connectivity part, everyone wants free. It is a plain vanilla thing now. And that also end-to-end, not only just access or international or national, but, and that is what end user want. So it's a very challenging thing. But what a network manager wants, and that is what we'll be discussing, they want a stability, reliability, and security of a given technology. They will use a technology if it can make the network stable, reliable, and secure. And also the cost of deployment and operation, the TCO, total cost of operation, as well as the cost benefit analysis, all those things is the actually problem of the network manager. So both are conflicting actually in a sense. IPv6
Recording in
enabler
progress.
Ubiquitous internet, actually this would have been covered already, and I'm going to skip except the last line. What we need actually to meet all these things are one internet which is open, agile, secure, trusted, accountable, and future proof. All these attributes have to come together. Some of them were already there in the original internet, the V4, V6 brings few of them to the table, and if we add blockchain there, then all of these can be achieved actually. So this is the key enabler, these things you know actually. Some of the killer applications which I've carved out for this presentation actually. In India, if you want anything more, because as you know, earlier thing was you cannot have enough of spectrum, then came you cannot have enough of addresses in V4 era. And so you can never have enough of these things, and that is what in India we call it a dil mange more. It's from a movie of the Shah Rukh Khan. I have taken this. So the starting point is what we call in India a broad-banded home. That is a killer application of V6, which actually came to known and showed its potential when during COVID in the last 3 years, we actually implemented work from anywhere, not just work from home, work from anywhere, SOHO, small office, home office, which have become a new normal. So when you have to work from home, your agent, your call center agent, or your office IT person or your office manager, you need a connectivity to the home which is secured, which is like a leased connection, or which is like a virtual private network, a VPN kind of thing, which every home cannot have, it cannot be afforded also, and then you need a fiber connection only to achieve that, or you need a dedicated IP address to create a VPN. So that when it was done in India, so the immediate requirement of the clients especially, and some of them are European or US, so they wanted their data has to be secured, and you cannot pass the data through just a public internet connection actually. It has to pass through a leased line or through a VPN. And for creating a VPN over the public internet, you need an IP address, which was not there in V4 due to NAT actually. In the NAT, what was happening, you already know, the operator will give to a data center maybe one IP address, and the data center, the user of the data to that center, they will have only a dynamic IP address. So you can never create a end-to-end VPN if your agent is not sitting at that place itself actually. So when he had to sit at the home, then the address shortage came to earth, and that is how these IPv6 helped actually. So in India, the government decided that any IPv4 address owner or any IPv address user will be getting the V6 address free of cost actually. So they were given, and they were given in bulk actually. And that helped in creation of a VPN, and that was even a customer provisioned VPN. The customer itself could provision a VPN if he had a dedicated or a static IP address. And with that, everything, the home became like a data center itself. The like edge computing, so many devices got connected to that, personal devices, office devices, and that is what solved the problem. That was one of the killer application in India. And now we are talking of 5G. The virtualization is the main thing where everything is being IP-fied or being automated, and that is where IPv6 helps. Cloud computing is another application because a lot of things, and that is where we need what you call unnet or net avoidance that only V6 can permit. And IoT actually, IoT is the main thing which needs IPv6 addresses because that is what we say in V6 actually. Not only each customer or each broadband user get a unique IP address, but each thing means each device, even each particle on the earth can get a IP address, dedicated IP address. So that is what IoT needs actually. As Cisco mentions, you will need 10 billion IP address only for IoT actually. The customer, the broadband customer in the world are only 4 billion and maximum they may become 7 billion maximum. But the IoT alone needs 10 billion actually. So that is where the IPv6 helps actually. And then these 5G actually, we are talking about 5G and 6G. So 5G also, and especially in the 5G, the slicing function actually. What the slicing does in 5G, you would have known by now, that the network can be sliced into different parallel networks actually, subnets kind of thing. One, let us say only for high-speed broadband, other can be a low latency connectivity, third can be a high-density connectivity, and there can be so many other slices. One slice is for autonomous car, a slice is for private networks, which is becoming a thing and a killer application of 5G, the private network. So you need a separate slice for that. So many slices. So one network will look as if there are 10 networks. So you will need 10 times more address in case of slicing if there are 10 slices in a network. So that V6 is the only solution actually which can support this slicing part actually. So basically, the main thing is the 5G and IPv6 convergence actually is fueling the innovation in anything we'll be doing in future, which includes 6G also actually, because of the inherent capability of V6 and inherent capability of 5G actually. And these are some of the reasons why IPv6 how they are allotting, and the top 10 countries, as you know, are the normal top 10 countries, and India is one of them. And one thing which I have to bring, and this is the latest one from Google, IPv6 country rank actually as on March 2023, the India, actually the number of IPv6 users in India are the highest in the world, what Mr. Latif also mentioned in introduction actually, though in as far as the adoption is concerned, because of the lower number of the internet user, the France has come above India. But if you count the numbers, the 400 million internet users in India are actually IPv6 capable actually. So that makes about 50% of the world internet users population kind of thing actually of the V6 users. Half of the V6 users are from India, and this is the latest diagram, and you can see this which we have taken from the ethnic website which have come as recent as last week only, and how it happened in India actually. That is what I should mention. There is a great initiative by the India starting with the regulator actually, and that was about 20 years back when I started, and I would like to compliment Latif also, who helped us in bringing out the consultation paper. Then government prepared the roadmap, then Telecom Engineering Center have developed specification for logo certification, and they have a CC lab for IPv6 logo, which is only second in Asia Pac actually. Then one of the operators started IPv6 20 years back. Government of India network called ARNet, Education and Research Net, is also conducting training. Then Reliance Jio, that is what now they have about 450 million actually of its customer on IPv6, though on the record it is about 400 million, but actually there are many more which are not fully validated yet actually in the ethnic website. Then there are other initiatives for capacity building, as I mentioned, and that is the key here. The IPv6 address are allocated free of cost along with V4 by NIXI, National Internet Exchange of India, through their local registry. And then we have also formed up, and that is where I'm responsible for, Bharat IPv6 Forum, which is as a cross-industry, all industries, all different actors like operators, ISPs, vendors, the regulator, all are together. It is an action-oriented think tank. It is just not only a think tank to advise the government, but it also takes up projects and helps in the execution part of it actually. So these are initiatives which were taken by the government, which are shown here, and something about economic value that is all well known actually. So I don't have to repeat these actually. So the strategy again worth repeating actually. So first, in government, the facilitation of efforts of the stakeholders regarding the adaptation of the IPv6, for instance, through awareness raising campaigns. Those were earlier days actually, when it was done. Earlier, IPv6 was not even known, and when it was known, they only knew that it can bring addresses and nothing else. But other capability of IPv6 were not even known. People were not aware, so how they will make use of it. Then there were detailed study were taken for transition from V4 to V6, and the experience gained through the networks within the country. All the ISPs were involved, and they were connected to V6 based networks even abroad, and making all major universities, research laboratories aware to implement a showcase for awareness creation among all stakeholders, ISPs, all that. And then the country people were actually actively motivated to participate in the different kind of activities, including establishment of a nationwide vendor skilling and capacity building program actually. That is what it all happened. And in policy side also, 2012 there was NTP where this IPv6 was mentioned clearly. The NDCP, New Digital Communication Policy 2018, emphasized for ensuring the transition to IPv6 of existing communication system, equipment, network and devices. And government fixed a strict last deadline, which ended 2 months back actually, 31st December 2020, that all the IPv6 ecosystem like ISP network, the websites, the all data centers, they should have the capability, dual stack capability, V6 and V4, which is almost there. And then there is a great thrust on skilling and capacity building actually through different arms of the government. And a roadmap was prepared, which have become a guideline now, a best practice also, where it was mentioned how it should be done, what are the deadlines. There was a formation of task force, three-tier structure, oversight committee, steering committee, and working groups actually. That was the key where, and first time in the government, the working groups, they were 10 of them, and they were all headed by the private sector. Normally, any government task force, the working group is headed by a government bureaucrat. But in this case, government make an exception. So the bureaucrats will be there, but the leader or the chair of the working group will be from the industry, because he knows it and he has a skill as well as skin in the game. So that is why, and it succeeded actually. And this status, which is latest actually, which I have already mentioned, And now the main thing, what I want to bring, which of course would have been discussed by now, the security and reliability with IPv6. And that is what actually is not well known actually. Till now, all of us have been knowing that V6 means infinite address, 3 trillion kind of address. That means everyone can get and play with the dedicated IP address. But that is just the one thing. The other thing actually, multiple subnets, which is a capability of V6, which is easier to separate functions and people. IPsec, which was of course there, a optional facility in V4, is actually a built-in or a mandatory thing in V6 actually. So here the security features are very, you can say, easy to use and mandatory in some cases, like IPv6 have what is called packet encryption, ESP, encapsulated security payload, and address authentication, AH. That makes the end-to-end communication more secured actually than the V4 or the earlier version of the internet protocol. Then the other thing which is well known, the absence of network address translation, which is not required. Why it was required? Because there was shortage of addresses. We could not afford to give a dedicated or a static address to each user. So we had to use NAT, which was a man in the middle kind of thing. And this avoidance of that, because now we have no shortage of address, so no need of NAT. So makes everything much more visible and end-to-end transparent actually. And security moves to the end host or end user actually and self-managed, because if he has a dedicated address, the end user, so you can trace, you can track, you can manage up to end actually. And then the latest one, which you would have heard from the earlier speaker or you will hear, and that is where the blockchain brings what is called CGA, which will be discussed. I'm not an expert, I've just taken from some website. Cryptographically generated address actually. What it does is actually it can in fact reduce the possibility of spoofing of address spoofing, because here address itself get, let us say, encrypted. So it will be very difficult to spoof it actually. So that is what this brings actually. And then there is a need, and I'm talking, of course, that is my personal interest, that I'm trying to create the capacity in the sub-region to have, to just develop, design what we call a DNS root server actually. As you know, there are only 13 root server and each country cannot have, because that is the limit in V4. In V6, there is no such list. According to me, each region should have a root server, not only for simplification or decentralization, but mainly for having the capacity to design, to establish, and to manage a root server. Because once you can do that, that means you have the capacity to make full use of the public internet, the existing internet. You can make it more efficient, actually, you can use it more speedily, and you can make it more productive actually. That is the purpose of my program, where we are trying to create, and of course it is easier said than done actually. A discussion is happening in the country with various stakeholders, and there are pros and cons for that actually. And that is why I say it is easier said than done. But there is a big case for working or spoiling our hands in designing, developing, and creating a root server, even if it helps only in learning and capacity building. And now when we come to blockchain, because that is what you will be listening more and more in this workshop. So according to me, like internet, we have 7 layers, the famous OSI 7 layers. For internet of value, that is what blockchain is known as. There are 5 layers: the hardware and infrastructure layer, data layer, network layer, consensus layer, and then the top layer is that sixth and seventh layer of OSI, application and presentation layer. The first layer, the hardware infrastructure, is what we already have. So you don't need to have anything new for the first layer of the blockchain infrastructure. Whatever we have fiber, we have 5G, we have towers, we have Wi-Fi, so that will work here as it is. So that is the first layer. The second layer, where the data layer, I'll call it what a data infrastructure layer or a digital infrastructure layer. First was a physical infrastructure layer, which is already existing. Digital infrastructure is where the blockchain starts coming actually. The digital signature, hash, Merkle tree, transaction. So that is all. The basic blockchain layer will come as a digital layer here on the top of whatever we have. And then the network layer, and that is where end-to-end, or what we call in blockchain peer-to-peer, because there is no middleman, there is no common control here. So peer-to-peer. And that is where the IPv6 will play a very important role. Because you can have peer-to-peer communication only if you have a dedicated address. Otherwise, you'll need something in between like NAT or a switch or a router. So that is what. And then there is a consensus layer. That is the main, you can say, brain of the blockchain. That is the real blockchain actually. The consensus layer. There is proof of work, proof of stake. There are so many things actually. There is a lot of debate going on, as you know, on proof of work and proof of stake, like Ethereum earlier was proof of work, now going for proof of stake. Some places Bitcoin use proof of work. So there are pros and cons for that, but each one have a play here actually. And then on top of that is application and presentation layer, where you have smart contracts, so many DApps and so many applications are there, and user interface through API. So that is how the blockchain works actually, and the role of your existing internet 4G, 5G is at the lowest layer. Only IPv6 comes at the second layer, and rest is all new thing which blockchain brings. And this I think would have been already covered also by someone, and so I'll not be going there. And this is what I was mentioning, that how Bitcoin, and that is the blockchain, can work with IPv6 and help each other actually. And that is the creation of what they have called, actually here a part of the hash, actually you have in V6 you have 32-bit address. So what it does actually, if your address is not encrypted, so then that means it is very, very transparent, and it can be hacked also, it can be spoofed also. So, but if it is encrypted, then your address becomes what they call pseudonymous actually. It is not fully anonymous, and neither it is transparent, so it is in between, it is pseudonymous. And with that actually you can avoid the spoofing of the address as is mentioned here. So I'll not go in detail because there will be other experts talking about this actually. Each device has an RSA key pair, no need of any certificate, because you have public key, private key, nobody in between, no certifying agency is required when you talk of blockchain. Everything happens through consensus here actually. Ultra light check for validity, prevents spoofing of a valid CGA address. And now what is next actually? That is where the blockchain, this seminar is about 5G, 6G, blockchain, cybersecurity. So all these things put together, blockchain, AI, IoT, IPv6, actually there is an intersection, this blockchain, IoT and IPv6, AI, ML, and that intersection is what is the future of the network actually. It is basically, finally it will result into what they call Web3, which will make all use of all these things. That is the future. And this, of course, again, IPv6 and IoT and blockchain, they are actually made for each other. And that you would have known by now, actually. And what I'm trying to do, and which I like to bring out the learnings from my own experience. what you need, actually these three things are required. One and most important one is capacity building at different levels in government and regulatory bodies. So that is very, very important actually, so that they can make a implementable policy, guidelines and strategy, and create in-house competency and expertise through hands-on training. That is very, very important, which have been missing in other part of the world actually. And then skill acquisition in core networking technology, that of course goes without saying. That is the hard skill kind of thing actually. And that is required for V6, for root server, domain name server, and also blockchain. So that is what is required as far as the technical or networking skills are required. And then research and development in new internet technology in academia. So all these three levels, the bureaucracy, the industry, and the academia. So different type of skills, they have to work towards that. And then only we can aim to achieve a secured, what I call secured decentralized public digital infrastructure actually. And I will now be concluding with this slide, though something I mentioned, but main thing actually here is that how it happened actually, the government role, the regulator role to bring India on top of the world map in V6 users actually. So all the different government agencies have played their role along with the industry. So it is the collaboration. And next, of course, is about the capacity building, skill building. And one portion I leave with that, and the portion is regarding the security of the internet by using TCP/IP. So there was a lot of debate happening last year that the present TCP/IP is not enough to handle the security requirement of 5G and 6G, and hence some other protocols should be brought out. So I personally feel actually that is not the right approach actually. So that assumes the internet is broken as far as 5G and 6G is concerned, which is not true. Actually, we have not used the full capability of internet protocol, especially IPv6, and also now we have not thought of the using the capability of blockchain, this cryptography part and encryption part and consensus part and decentralization part. So if all these can be put together, then nobody can dare to say that internet is unable to, the earlier internet, that is TCP/IP, is unable to handle the security requirement of next generation of telecom network, 5G and 6G. So that is why I like to say, don't try to repair something which is not broken. Instead, upgrade it to V6. So with that, I like to thank all of you for this patient listening, and I wish you all a very new and happy, secured internet. Thanks a lot.
Thank you, Satyan. You are an absolute legend in the IPv6 world, and especially fixing India, as India is not one country, it's multiple countries in the country, and with single-handed, over your mission for the last 20 years to make this happen is absolute, an amazing achievement. That's why you have received the Lifetime Achievement Award for that. Congratulations to you. So it's a rare example on this planet to make such a thing happen in an impossible country. India is not a simple country, I know that. So I was very astonished about what a single man can do in a very tough country. Although in the other countries we have communities and many government committees and so on and so forth, and they can't even fix it. So I think there is some hope on this planet that in each country there is for sure somebody who can do similar work like you have done. So your roadmap is absolutely exemplary. Since we don't have much time, because I know you have answered all your questions on your slides, So if I allow them to ask you questions, we will not finish. So we have the next speaker who will be introduced. Thank you very much. Take care of yourself. I will talk to you next time. Goodbye.
Thank you. Thank you. Thank you, Latif bhai. Thanks a lot for the opportunity and kind words. Thank you.
Thank you. Back to Mr. C. Abdel Latif Gabon, trying to fix the unfixable. Make it sound, very difficult. So, yes, correct.
Hello. Okay, excuse me for this the slides. I would like to thank Professor Moayed Al-Ghaidi. Professor Moayed received her MS degree in electrical and computer engineering from Concordia University in Montreal, Canada, 2012, and also PhD from University of Ottawa, 2016. And actually now he's managing director of X Analytic Company in Canada since 2019, and currently he is member of machine learning department from Mohammed bin Zayed University of Artificial Intelligence. He working around research interests include the application of AI and machine learning connected and autonomous vehicular blockchain solution and sustainable energy and data management. Now Dr. Muayyad give a talk about cybersecurity and the blockchain. Thank you very much, Muayyad, for to present here in Morocco, and the floor is yours.
Thank you very much, Dr. Abdul Latif. I really appreciate this invitation. First, before I introduce myself, I would like to thank the organizer, Professor Abdul Latif, Professor Latif, and all the people here. Of course, we can't forget the generosity of the university for hosting this important event for our students and our academic faculty members. I have been here for 2 days, and this is my first time ever in Morocco. I mean, I would say, before we start this, that we should give some big thank for the city and their people, the nature, the food. Everything was amazing so far. I really enjoyed my time here, and I would do it more often. Okay, so going back into our presentation today, I mean, we had in the morning two interesting presentations. One about the historical and the overview of the internet and our protocols and how the evolvement from Web 1.0 into Web 3.0 using IB version 4 all the way to IB version 6, and the crucial need for that, presented by Professor Latif. And on the other side, the really needed into the rejuvenated all the infrastructure of how we deal with the transaction over the internet. So do we really need banks? Do we need fiber optics to transact money between banks, or we just can rely on peer-to-peer transaction in a blockchain? So today, my presentation, I'm not going to spend a lot of time on why do we need a blockchain is important or not, and all of these things. More of a like, I'm going to focus on a blockchain-enabled cybersecurity and the role of a blockchain in cybersecurity and preventing, catastrophic event. So after that, I will talk about two important use cases, and I'm very happy because those two use cases is complementary use cases of what Owen already in the morning mentioned. He talked about the crucial healthcare system and how can direct IB to IB transaction can help healthcare system. But we can talk about two important applications. One is metaverse, and the second one is peer-to-peer trading, like peer-to-peer energy trading, peer-to-peer transaction on individual level without the need for a third party or centralized entity. So a little bit about me. Again, thank you, Professor Kopan, for the introduction. My name is Muayyad Al-Okeli. I did my study in Canada, and I work right now in Mohammed bin Zayed University of Artificial Intelligence in Abu Dhabi. I am the founder of the Artificial Leap in the university, and we have a big group working on the security of 5G, 6G, blockchain solutions, and cryptographic solution. So if you need to know more about me, or if there is any student here, he is interested to pursue master or PhD, our university is a graduate-based level university, and they are offering some scholarships, so you can find more information about it from the website on the slides. Okay, so a blockchain is known since ever. It's a public distributed ledger. And the basic inception of why we need a blockchain is to stamp digital documents. So in the past, they used all of these digital documents, but they wouldn't have a way to verify the authenticity of those digital documents. So someone might come, play with these digital documents, change the value on it, change the date, change the signature, the cost value, without a way to find out who has tampered or has played off this digital document. So a blockchain is not a new technology, it's a very old technology, but it came to effect with the advancement in computing and computation in our today's devices, and it's enabled that individual use in their basic computers, they can, employ and run a blockchain technology. And this is what we are seeing in these days in cryptocurrencies, Bitcoin. Anyone can trade, anyone can, use the cryptocurrencies. So basically, the distributed ledger, it's open to anyone. So anyone can own a blockchain, anyone can establish a blockchain network. We can have our own blockchain network here inside the university, inside our classrooms, and we can trade our own, commodities. It is super unique concept that it's impossible to change the records data, what's it's, served or preserved on the block. So the block is known for its hash unique, cryptographic solution where the 128-bit is pertinent to the data. So any data stored in the blockchain cannot be tampered. It cannot be changed without changing the hash. So if the hash change, you will be able easily to detect that this has been manipulated or the data has been, changed by someone. So all the network connected to this will know about it. And some of the progression in the blockchain protocols, the first one in 1993 up until 2018. So I think a couple of months ago, about 6 months ago, we have moved from the use of a proof of work, POW protocol, into the proof of stake. And as you can see from the slides, that proof of work here, it's a decentralized but high energy consumption. So the mining people, they were finding a lot of a problem because it's slow and it requires a lot of energy. And this is mainly used to secure the Bitcoin transaction, and every transaction requires a 10-minute to be created. So up until the 2008 year where we have the avalanche, and it's fast, scalable, and adaptive, and it's not widely tested, but it's expected with the open source development in it to have a lot of adaptation. But the most one that we are moving and we are, having a lot of development even in our research paper these days is the proof of stake, which is energy efficient and fast, centralized risk, of course, but the most important, it has a fast, a creation of the block comparing to the proof of work. So as we can see that a blockchain, it has a limitation when it comes to the computation and scalability, but at the same time, with the new adaptation of lightweight protocols like a proof of stake, like DPoS, and so on, we will have more a lightweight protocol application to be deployed on end devices very soon, or maybe smartwatches. Now, when we talk about security stack, conventional security stack, before the invention of the IoT devices or Internet of Things or Internet of Energy things or everything, the security mechanism, it was traditional. We started from what we called application security. I have an application, I implemented an application, and I want to make sure this application is secure. Then we moved from application security into system security, and this is what Professor Latif mentioned in the morning, that we need native AI. We need to embed IP version 6 within the operating system to have more robust, operating system. We cannot just embed it at the last level network, network layer. So application security, it's a standalone application. Then they moved and said, this is not enough to secure application independently. We need more of a system security. We need to secure the entire system from the ground up. Then they said, okay, application system, but we have an infrastructure. I cannot just secure the application and the system of the College of Engineering in the NCI University. I need my whole infrastructure, my entire country, Rabat infrastructure, to be secure. And this is a complicated task because you have to rethink your entire system, application, devices connected to your network and their security mechanism. Then the information theory people, they said, oh, but this is all about devices and hardware and their security, but the data flow, the information flow in the network, it's another story. It has its own cryptographic algorithms, it has its own issue in terms of complexity and security. Then the last thing it comes to encompasses more of this is the network security. So my information is a flow in the network. It is being exchanged from one device to another. When you send a message from WhatsApp to WhatsApp, the message goes through a subsidy of network. So this is what we call network security. But in all of these traditional security stack, there were three main questions that keeps arising. The first one, who accessed the data, who changed on the data, and when the data has been changed. So that was always the main issue. So whether the data in the network or at the application or in the system or at the infrastructure level, always you need to know who owns the data, who has access to this data change. Because when you want to do an audit and you want to do a trail of that on a network audit to see why the data or why there been a failure, you need to know when in time this problem happened. And here we have the notion of a blockchain, because a blockchain with its a transparency, consensus mechanism, openness and robustness protocols, it allow you to secure those three questions. Because at any point of time, if you use a blockchain to transaction on the network, you would be able to answer who accessed the data, when the data has been accessed, and when the data, in case of exchange, has been changed. Now, it comes all about a blockchain, and a blockchain is fancy, and it provides me with a greater tool and mechanism to secure my data and move forward on the network side with firm hand and firm leg. Now, let's come to the cybersecurity itself. Cybersecurity notion, in the past, like maybe 6-7 years ago, there were no cybersecurity. We were only concerned about security and privacy. Security is about systems. Privacy is about our information and personal data. But now with the emerging, and evolving of the cloud systems, the whole, security and privacy mechanism has changed. So now we are talking about cybersecurity. My data is not locally on my device and my phone. My data is in the network. I don't have a copy on my phone of my data. Most of our data these days, it's either on Google Drive or Dropbox or AWS. So, okay, in case of my data lost, so what will happen? How am I sure that my data with Dropbox or Google Drive is secured, is not penetrated, is not someone else is used it? And this permit to a new terminology called cybersecurity, where it's mainly to protect the interconnected system, hardware and software. And this is what we called native secured system. Native secure system, okay, where's the loophole in the system so I can secure it? No, I need to rethink the whole thing, that by design, from the point that the software engineers start designing the system, they have to consider security architectures. So the second thing, the safeguard of network devices, sensitive information, and the cyber threats on those information, it's a cybersecurity also, a greater techniques. Moreover, maintaining the confidentiality, the integrity, and the availability of the digital asset on the cloud platforms is also related to the cybersecurity. And the last, it is more of a modern technology that it's essential for the smooth functioning of businesses and enterprises. Okay, now we know what is a blockchain. We know what is cybersecurity. So let's look at the advanced mechanism that cybersecurity is offering these days. And most of these things that I'm going to talk about it in this slide, it has not been implemented in our daily lives or in our technologies a few years ago. The first one is the multi-factor authentication, or the two-way authentication. So in the past, if you remember, you used to open your email just using your username and password, right? But these days, when I came to Morocco, I couldn't open my email because he said there is a suspicious activity. You are trying to open your email from a different location. Your usual activity that your email, you open it from UAE in Dubai. So now he was able to be more intelligent and detect that you are opening your email outside your usual activity. So there is multi-way or multi-factor authentication. So he has to send me what they call it, OTP, one-time password. Another one is intrusion detection. If someone is trying to intrude on your network and implement any malicious behavior on the network, it also has a mechanism to detect it. Network segmentation, threat intelligence, which is when we talk about native AI in our network, or intelligent detective, adaptive manners, and so on. Endpoint protection and quantum cryptography. All of these is a new mechanism, and it's a fancy mechanism to improve the cyber security in our network and at our application and systems. So now, a lot of people look at the blockchain as it's a complicated technology. It is not easily usable and implemented in our system, but on the contrary, now, Owen, in the morning, you were talking about in-chain. In-chain, if I'm able to transfer a transaction between two individuals, why do I need the bank? Why do I need the bank? I have my digital wallet. I got into agreement with you about certain transaction through a smart contract or any kind of certificate. You have the trust, I have the asset. You give me the payment, I give you the asset. So there is no need for a central authority in the middle to add extra fees, to add extra, bottleneck, control my asset, and, complicate things. So now a blockchain, it's being seen as an enabler for cybersecurity. It's mainly for access control, security, but it can also help in many other features. Here I listed 9 features that of the role of a blockchain in cybersecurity, and I hope those features for the student in the stadium with us today, that they can look into this feature as a research topic, because those really the latest in the market these days when we talk about cybersecurity and blockchain, with the the flavor of AI, of course. First is the decentralized identity management, secure data sharing, immutability, audit trail, zero knowledge proofs, smart contract. I will give you some resources in case you want to explore more. Decentralized identity management. This is an ancient problem, even before I born. Should we stay centralized, rely on a server that has since ever realized? So it's first conception that I don't need someone in the middle to control me. I and you can manage our own asset and our own, finance all together. So decentralized identity management can be provided by blockchain, and it can improve the data security and data sharing. When it comes to that, to data sharing, I mean, imagine that a blockchain through the peer-to-peer transaction and the decentralized management. So you manage your own data the way you want it. So you have some data that you want to share it, and others you don't wish to share it at this point, or you wish to share it with only a few people. And this is what the blockchain can enable you when you use secure data sharing. On the contrary, when you put or when you upload your data on the cloud, you have no option. They have all your data. And you don't have control over your data. And if you read between the lines, even if you delete your data and your account on the cloud, your data is still at their server. So this is another issue of why we need to move from centralized to decentralized. Secure data sharing, management of my own data, control over what data to be shared over the network and what data to be kept private for my own use at my own time. So another thing is the immutable audit trail, and this is, I believe, this keyword you have heard it a lot when you talk about, or when you hear about the blockchain, immutability. Immutability, it's basic concept that the data is immutable. So you cannot just change the data whenever you want on the blockchain, because we are promising the users that this technology is safe and secure. Hello? Okay, it's safe and secure to put my data on the blockchain network. So I cannot later on change this concept by allowing anyone just to play on the data. So the data is always connected to the hash. Whenever you have any change on the data itself, the hash will change, and you will be spotted inside the network and broadcast it to all the participants that the data has been changed, so they will be notified. And in some instances, the entire network will be deemed ineligible to be transact. So immutable trail, it allow you and give you the feature and the organization to create immutable data trail that logs every transaction in the network, and this will easily help organization to track down malicious activity and prevent cyber attacks. Zero knowledge proofs. So this is known issues in audits. So when an audit happens, people knows who performed the audit in your data. And so there's two issues here, that he has an access to your data, so he sees your data. And the second one, you know who accessed your data. So now things get personal. With zero knowledge proofs, a cryptographic protocol allow one party to provide the authenticity of certain or many pieces of information without revealing any additional information. So it's like a black box. I give you a black box of data without knowing this data for whom, and I will ask you, please make an audit or zero proof knowledge on it to provide me with a cryptographic, hash function. So this is one of the biggest problems that it's being tackled by two communities. Cryptographic community, which is the information security people, and also the network and security application people. A smart contract, it was and it will be always of an interest to be used on the blockchain. Most of the people, they look at the blockchain, the smart contract, that it's not the case. Any two parties who have an interest of any kind of commodity, they can get into a smart contract and they can exchange any kind of digital assets. So smart contract, it's more of a like exact similar contract. When you go to rent a house, the first thing you do is you write a contract, you sign the contract, and you provide the checks. So it is the same story, but it is a computer program that allows two people to get into an agreement, but the only unique value that this agreement cannot be changed. So once you get into the contract with me, it's not up to me or to you to break the contract or change it. The contract, once the contract terms is done, so it cannot be broken or changed. Secure digital asset transfer, Owen talked about it in the morning, and Chain is providing, and BSV, a lot of activities and a lot of development on how we can secure digital asset, our individual wallet. So we have a wallet similar to conventional wallet, but your money is not physical. Your money, it's coins on the wallet, and you can use this wallet, by transferring the digital asset on it. There is a lot of argument from the banker system that this is not a real currency, but how many cash we have in our pocket these days? All our cash in the bank. We use the credit cards. I mean, we barely have a couple of $100 of dollars or dirhams in our own wallet, but the rest of the money is in the bank, and we are dealing with cards. So this is digital asset. But on the blockchain, it's the only thing that here it is peer-to-peer. So there is no middleman, there is no middle retailer in the middle who can control and put fees and give us this illusion that it's needed to achieve specific transaction. Now, before I move to the next slide, which is about that we have a blockchain, cybersecurity, and AI. It's one of the most important feature at the network level is the decentralized threat intelligence. So now we are promising that we were going to move everything decentralized, but this is also bring a lot of problems, because being decentralized also bring a lot of benefits for the attackers, for the security, from the security perspective. So now I have more grounds to attack people. Not all the people, aware of the security issues, and they can, safeguard from it. So a threat intelligence, it is more of a use of intelligent technique. It's like a plugin. You employ it in your system, and it will at least give you a threshold of the basic, threat that can attack your system. So mainly how we can use decentralized threat intelligence is by collect, analyze, and share a threat data from a historical event, aggregate these data, aggregate this, and learn from it, provide real-time, forecasting and, monitoring over this threat, and eliminate the risk on a real-time basis. Now, into the next, this presentation also it's not about also understanding that I have a blockchain. It's provide me with a secure access or an fancy access control over my data and my asset. We have the cybersecurity, and we have seen that a blockchain is a fundamental part. It has a big role in securing the data sharing, the digital asset, the transaction, and all of that, and improve the cybersecurity of our system. But on the top of that, we have not to forget the role of the artificial intelligence. I'm not going to talk about it a lot these days, but as a student and teachers and academician and even policymakers, we need to take extra care of transforming our current system into more intelligent systems, whether at a blockchain level or at any other levels. So now a blockchain can benefit a lot from the AI when it comes to the scalability, because it can learn fast and adapt to the new situation and to transform the digital asset quickly. So in this scenario, employing AI with a blockchain, I can put it in 5 spaces or 5 research topics. First, situation discovery, pattern awareness, predict to future situation or future scenarios, decision making, and a proactive mechanism solutions. Okay, now let me move to the last piece of the presentation, and I hope that in the future and during the lunch we can talk more about this application and these technologies, because within 30 minutes you cannot go deep and discuss the fine details or more of a technical content. So I'm trying here to provide the big picture here, and we can discuss maybe in further meetings and further gatherings about more technical issues and the potential solution of those issues. The first use case, and I know many of you heard of it, and a couple of the people here already, they approached me. The gentleman here talk about education and metaverse and how we are without metaverse these days. Education seems has a lot of issues. And we wish during the pandemic and COVID, we had metaverse and our students or our children's, they were more of an interactive environment, but rather not just sitting at home dealing with MS Teams or Zooms. So now metaverse, it's a one-go technology. There is no way back. Big investors, they investing in the metaverse technology. And I see that in a few years that a lot of our system and our companies, we will be a service providers for the metaverse. So we're hearing about metaverse streaming, metaverse as a service, metaverse for education, for healthcare, for telesurgery, for many of those solutions. But now, I mean, this is a new concept where all our data now will be moved from the two-dimensional physical space from servers into a new, technology writing. We don't know anything about it. We have no experience about the potential threats because we are still exploring, we are still developing. There is no, for example, IEEE standard or ISO standard or IET standard for metaverse, communication as we have in IEEE 802.11.p.a.x. So this is still in the early stage, and this is very important for our student to start researching about it, developing about it, finding potential solution, and communicate it to the research community and to the research industry as soon as possible. So now, one of the 5 pillars that we need to look at when we talk about blockchain, cybersecurity, and metaverse is security of the identity management. We have 2 types of a blockchain, public and private. Similar to the cloud, we have public cloud and private cloud. In the public metaverse, anyone can join. Anyone. Imagine of dating apps. Dating app is the best example for public metaverse. Anyone can create an account, or like Facebook. Facebook is a public metaverse. Anyone can create an account and share his data. But do we know the identity of this person? It's not known yet. And in the context that I discussed it with people, they said public metaverse is meant for unknown identity. I don't need to share my real identity. It's public. Why? Then we have the private metaverse. Private metaverse, this event can be a private metaverse because it's only for people registered. It's inside the university. Not anyone on the street or anyone from around the world, they can join and enter. In both cases, there is a huge intake on the identity management. The people who join the metaverse and leave the metaverse and conduct any kind of business on the metaverse, they should be securely identified. The second problem is the decentralized data storage. So when you join the metaverse, so you have to share your part of your data, part of your traffic. So we need to look into also how our traffic or our personal information and data is being managed inside the metaverse. Security of the transaction transparency, and this is definitely, as I said it so many times, and the people here confirmed it, that without a blockchain, you cannot run metaverse, because there is no way that I will guarantee to share my information on the metaverse if I'm not sure I am the one who managed my transactions. And the last one is a smart contract. Definitely in the private metaverse, for example, Dubai government, they announced that they have invested 500 million in the Pandora box, and in 5 years plan, 30 or 40% of the government services will be conducted on the metaverse. And this is a great initiative. So instead of going to the Ministry of Transportation to renew my driver license, and I visit and find a parking and go and talk to people, everything can be on the metaverse. I can join the platform and I can talk to someone while I'm in my office or from my home or from my car. So now, in the private metaverse, when you want to conduct or receive service, there is a service that you want to apply for it, because you apply for the service, you need to pay for it. So how are you going to pay for it? Definitely through, I hope, through peer-to-peer transaction, IP to IP, or more or less a smart contract. The second use case, which is also a very important and it's very close to my heart use case, is the peer-to-peer energy trading and sharing. And it is known worldwide that energy, it's a big topic. The lack of energy all over the world, it's a big topic. And there is a lot of effort on integrating renewable energy into our conventional power system so we can create more energy. And in some part of the world, like the Gulf and the African countries and the Indian countries, it's very hot countries. They can produce a lot of energy from the sun. So, and in some of the renewable energy initiatives in Dubai, they produce energy more than what they need. So what they do with the rest of the energy, they produce it. So the easiest solution, they can sell it. They can sell it to the other, adjacent territories, other countries, or they can, make it for an auction. So now, the only issue here, which is what we want is peer-to-peer transaction, that if I am as an individual and Dr. Muhammad as an individual produce our own energy, we are in the same neighborhood, and I need extra energy, and he has this extra energy that I needed. So he wants to sell it to me. So how can I buy it? It's very simple problem. Now, if you want to buy a pack of cigarette or a bottle of water, so you go to the market, you give him 3 dirham, he gives you the bottle of water. So this transaction is done, right? You have the commodity, he has the money. But in the case of the virtual commodity, whatever it is, not even energy, healthcare transaction record, diploma certificates. So how you can ensure the authenticity of the transaction, how I will trust him to give him the energy, and how he will trust me to give him the energy, and I will trust him so he can give me the coins or the payment for the energy. So this can only be done through peer-to-peer transaction. Two people, they don't know each other, they have no knowledge whatsoever about each other in the past, they don't trust each other, and they want to execute a transaction. So how they can do that? They can do that through a blockchain and smart contract. So this is the concept of energy production. So whether it's a house, a smart car, a smart utility, they produce energy and they trade it among each other. And they can also, if they produce enough energy, they can sell or trade energy with the conventional power systems or retail trader. So here, there is a missing keyword here, it's called federated grid. So there's 3 main research areas in this topic. The first one, I can trade inside the microgrid. Inside the microgrid, so 2 people in the same neighborhood or in a community, small community, they can trade among each other. across microgrid. It's an example where Rabat and Tanja, they're very close to each other. So people from here, they can sell or trade energy with people from there. And the last one, what we called it, energy sharing. And this is another concept. Energy trading, people trade energy for money, for coins, for Bitcoin, for energy coins. Energy sharing, it's more of a consensus system, like game theory. People, they don't have money to trade in, to buy energy. On the contrary, they have energy to trade it in the future. So it's like equilibrium. We all take care of each other, and eventually we all will have enough energy during over the year. So now such system, whether you want to trade energy for coins or you want to share energy, this is my last slide, or you want to share energy, how you would do it, how we would do it. So if we want to start an renewable energy initiative here in Rabat tomorrow, so the only way to go forward with individual in our countries producing energy, share it or trade it, is through the use of a blockchain and individual IB to IB or peer-to-peer transactions. Thank you very much. I wish I have more time to talk about these topics, hopefully in the future, or if you have any question, you can ask me. And again, my deepest thanks to the country, to the organizers, and to the kind people who attended the presentation today. That was really very dear to my heart. Thank you so much.
If you have one or two questions.
Thank you, Professor, for your rich presentation and talk. Welcome in Morocco. Rabat is a nice first step, and other cities like Tanger and Marrakesh are nice too. I have two questions. The first one is about your fifth slide, and I like the fact that you summarized the progression. This one. So the progression from Bitcoin, the consensus mechanism use. So it's quite known in the literature, the blockchain trilemma. It's security, scalability, and decentralization. When I look to this tableau, I'm asking the question: what is your point of view? Should we lose decentralization to get security and scalability? When you can see this progression, and what's your point of view? The research directions. What is your point of view? My second question is about the use cases. I'm quite interested in I'm already in my research. The second use case in trading energy is relevant, I think, for blockchains. My second question is about the first use case in metaverse. We are in a step when the adoption of blockchain isn't, I would think there is a slow blockchain adoptions. The fact if you want to use it in a new or emergent technology like the metaverse from Facebook, isn't it too early? The two questions, blockchain trilemma, your point of view. The second question about the use cases. Thank you very much.
Okay, thank you. These are indeed interesting questions. So now, about my point of view, definitely we need to move to decentralized at one point. So, the notion of centralized was originated by, businesses. And because they want to keep controlling of our data. So similar to the email. So you will be a slave to the Outlook and Gmail to the rest of our life. Why? Because it's centralized. Our data there, God only knows what happens to our emails, who read it, and how they sell it. So, the day I landed in Rabat, I received 10 emails about businesses and restaurants and things that I should visit in Rabat. Who knows that I'm visiting Rabat? Because when I booked my ticket, I received the email. The email directly goes to my Google Calendar by default. I didn't even add it. So everything is, is exposed. With decentralizability, at least we will never reach 100% security, but at least you will have some control over some of the sensitive information that you wish to keep it private. So in my point of view, that decentralizability, it need more effort, but it is the way to go to have more control and reduce costs on individuals. For the second part is the the metaverse use case scenario. Definitely, if you want to deploy a full blockchain solution in the metaverse is too early. Metaverse itself is too early. I mean, we talk about the conceptual things in metaverse, but we don't have a fully verified, solution with known protocol from a known standardization that we can deploy it in our system. So there is very little information to go with the metaverse, and the effort is ongoing. So now, when I'm talking about looking, now we are at the research. At the research, we can dream, we can go wild as much as we want. When it comes to the real case scenario, we can use more of, objective function to limit our dream. But definitely, one thing that no one can argue about is that if you want to conduct any transaction on the metaverse, it should be through blockchain. Otherwise, our data is already exposed enough. So what about I expose it on a digital replica of a virtual platform? I don't know who was there and what they are doing to my data, my kids' data, my personal information, and so on and so forth. So at least the transaction can be conducted on the metaverse. And don't forget that metaverse is not meant for the regular IP version 4, and it's not meant for the LTE and 4G and 5G. It is only meant to be used with tactile internet. If you want to deploy it, for example, telesurgery, or if you want to do a musical concert where thousands of people attend it. If you want to transmit a real-time interactive experience of a musical concert or a soccer game, major soccer game in the major leagues, into thousands or maybe millions of people in a real time with sub-milli latency and high precision and zero latency synchronization, you cannot do it on our current networks. You need a specified network, which is what we call 6G and beyond, and the tactile internet. So this will be helpful in relying on the 6G to transfer this real experience, interactive experience, and to embed the transaction between the parties, the multi-parties. Thank you.
Thank you very much, Professor Muayyad, for this interesting talk. I give you your gift.
Sorry. Yeah. So our next speaker is Dr. Serjan Greco. He's the president and CEO of his own company, Dunavnet, in Belgrade, in Serbia. As a matter of fact, he's also with me, a board member of the IoT Forum. And he organized some of the best conferences in Europe. So I see you're already on. As a matter of fact, he has a very huge EU project called Demeter. Demeter is the Greek goddess of agriculture. So this project is about food supply chain, among other things. Serjan, can you hear me?
I can hear you, yes. I hope everything is working fine.
Absolutely. Go ahead. Thank you.
Okay, perfect. Thanks, Latif, for the introduction, and good morning, afternoon to everyone. Sorry for coming there. I was there a few years back, and it was really a great time, but hopefully next year I'll manage to come in person. So I'll be talking about transparency and how this whole blockchain concept fits in, but more from the application perspective and what different domains, mainly coming from the agri-food supply chain, are looking for, why this transparency is important, and how blockchain could help. Blockchain and all the other related mechanisms and protocols. So just a few words about myself. As Latif mentioned, I am a CEO of DunamNet. We are a company that's designing and implementing turnkey solutions mainly based on IoT, Internet of Things, and AI technologies. We target agriculture and manufacturing as the main application domains, and we've been doing this for quite some time. We are partners with Microsoft, with SAS, with some of the larger industrial companies, and that's on the commercial side. And on not so commercial side, we do participate in a lot of EU-funded or co-funded research innovation projects. And what I will be talking about today is mainly coming from these projects. So how smart agriculture is addressed in the EU project and where transparency fits in there. So one of the I think, two largest projects funded by European Commission in the Horizon 2020 project very popular topic, and you have a number of different solutions that are being applied there, different types of sensors, different types of analytics. A lot is going there. And when it started, somehow, especially from the startup perspective, it was, we built very focused solution. We just built a solution to optimize irrigation of corn. And then another startup was doing optimization of irrigation for rice. And then you can imagine that there are many different operations and activities on one farm, and we ended up with a lot of companies providing these small solutions or addressing very, very specific needs of a farm. What was realized then later on is that the farms are not just isolated activities. It's a combination of a number of activities that is happening simultaneously, and many of the farmers would not have just corn or just rice. They will have multiple crops that they are dealing with, and a number of machinery, number of workers, etc., etc. So a much broader approach was needed. So different agriculture platforms started to appear that are addressing more of a farm as an integral activity, not individual activities that are happening on their own. And the next point was, okay, so how do we make these platforms, these solutions work together? Because in some cases, someone can have very good solution, a good disease model. How do I integrate that disease model with the rest of my functionality? How do I combine functionalities from different solutions so that I as a farmer, can have a really nice and efficient way of using all the data that is being collected. And Dimitar was and is still trying, its project is still going on, to address that particularly, this interoperability of all the different solutions that are available on the market. And the main contribution there is the agriculture information model that is used to describe the farm, describe the crops, describe all the activities that are happening on the farm, so that once we have different solutions talking, they can at least have the same language to use. The project is quite large, as you can see, 60 partners across all of Europe. My company and I personally are responsible for coordinating all the pilots. So there are 20 plus pilots from Norway to Cyprus and from Ireland to Georgia. All the pilots are split into 5 clusters. Some are dealing with arable crops, others are dealing with machinery, then fruits, vegetables, livestock. And the last cluster is dealing with, it's more cross-sectoral, and it is dealing with the full supply chain. And there, the interoperability and transparency are among the most important topics. So once we move from one farm, and we say, okay, we have inputs coming to a farm, we have outputs, the crops, the animals, moving to the next player in the supply chain, and the next one, and then eventually coming to the shops and the consumers. How we track all of that? What are the mechanisms? How we can do it efficiently without making life for the farmers and all the stakeholders even more complicated. So that's the focus of some of the pilots in this cluster 5, and I'll tell you a bit later what we have done there. Similarly, another project now, also from Horizon 2020, it's dealing and it's focusing on transparency, solely on transparency in the wine supply chain. And there are a number of partners, some coming more from the chemical analysis perspective, others from the ICT, third from the winemaking perspective. And here you see that if you come into the chemical analysis of wines, there are multiple parameters that are being measured, that are being monitored, that are important first to create the wine that you want, to maintain the quality of the wine, but then also might be important for the next player in the supply chain, and maybe eventually also for the consumers to some extent. The other part, as I said, they're dealing with the actual winemaking process. So the irrigation, the soil nutrients, what to add, when to harvest, what type of grapes to mix, where the grapes comes from, how long it was between picking the grapes and putting it into the barrel, squeezing it, etc., etc. So there are a number of activities there that are important, and that can be important also from the perspective of other players in the supply chain, and how you transfer that information, how you make it interesting and legible for everyone else. That's something to be discussed and to be addressed. And finally, there are some ICT people in the same project that are trying to put everything together. And I won't go into the details of this, the schematics and all the databases and the different IT tools that are used there. But it is, as you can see, a rather comprehensive set of features that you need to be able to collect all the data from vineyards and then from winery, warehouse, transport, distribution, retail, consumers, recycle. So quite a long supply chain. And you want to be able to collect data from all these different steps and also to enable everyone to use the data and find the data from other steps that might be of interest to them personally, and to find it in a way or have it in a way that is useful for them. So that's another example of project that is dealing with this transparency in the food supply chain. And I'm trying to show how much data is there and how much data is generated and how many different stakeholders are there. And that's why it's a bit complicated to put it together so that you have something that is easy to use, that people can trust, and that you can actually verify, that you can, once you get the answer, that you can really be sure that the answer is valid, and that you can trace back that answer all the way down to the raw data that was collected maybe in a vineyard or on a farm. And the third example is a relatively new project that started 6 months ago, Fish EU Trust, and that's about farm-to-fork monitoring of the fish farming. So now we moved from land to sea, and this was, for me, it was a new domain. I spent a lot of time looking into orchards, vineyards, poultry farming, but the fish farming was and still is something new to me, and I wasn't sure what to expect there, what type of parameters they are collecting, what are really the problems with the fish, and why transparency is important. And because we have in the project that, oops, now I'm moving in the wrong direction, because we have in the project quite a few companies and organizations that are with a long experience in the farming, in fish farming. It was very interesting to see how they look at the transparency and traceability of that supply chain, which are the most important objective of the project. And we have, as a way to address this domain, we use this concept of living labs, co-creation living labs. And just recently, last month, we had a project meeting on Malta, where I had the opportunity to listen to people coming from different perspectives that are deeply involved in fish farming world. Some of them are providing instrumentation for fish farms, others are fish farmers themselves. The third ones are providing a lot of testing and different types of chemical analysis for fish farming. There is also a distributor of fish and fish-related products. And understanding the complexity of that supply chain and all the different things that can go wrong, or that people at the moment are trying to cheat with in order to gain some commercial benefit, some financial benefit, it's really amazing. And understanding how to address it, how to solve it, it's a challenge. But what I understand now is that what we have been doing in the wine supply chain, or maybe more of a arable supply chain, and those type of activities, that's the same setup you have here as well. You collect a lot of data, you have to do a lot of analysis, you have farmers, you have distributors, you have shops, retailers, or consumers, and the problems are similar, be it fish farming, be it winemaking, or poultry farming. So there is potential to use the same approaches to solve all of these problems. Another thing that is also coming now to play, which is adding more of a complexity maybe to this whole transparency of data perspective, is the concept of data spaces and data monetization. So far, the farmers are mainly collecting data, or service providers are collecting data from farms so that they can provide information, they can provide insights, recommendations to the farmers. So data is collected on one farm, and then the recommendation is provided to that same farm. But that data that is collecting on a farm might be also useful for other farms, or for other service providers, or for insurance companies, banks, governments. There are a lot of people who might be interested in that data. Not so much data of a specific farm, maybe, but data in an aggregate. But that aggregate is only as good as the inputs from different farms are valid. So how this whole data space concept cannot work unless we have quality data that is inputted, unless we can trace back to where this report, how it's made, which data was used to make that report. And also, without enabling farmers, the owners of data, the ones who enable collection of data, can get remunerated appropriately, so they can also control how their data is being used. So there is that now transparency from that perspective, where the data comes from, how is it quality data, who approved the data, who said yes, it's good, whether annotations are good, and how to track where the data is being used. So another perspective of transparency, but still yet another layer of also complexity. So, and in that context, you can have farms as sources of data, then you have to annotate data, put it into a context, do machine learning training, do validation of some AI models. It's also another market that is coming up. So a market of machine learning models, or AI models. So how if I'm buying an AI model from someone, how can I be sure that it is valid, that it will be working fine, how it was validated, where it was validated, what data it was validated on, and how to make that that information transparent, in a transparent manner, in a trustworthy manner. That's another issue. And these are all now challenges that are being addressed by these different data space related projects. So what happens on the farm is that you have, Agronet is our platform for smart agriculture. You have other platforms. So in principle, all these platforms are collecting data from different sensors, different types of machinery, from ERP systems, from weather forecast systems. So there are a lot of different inputs. You put everything into one kind of a place, one database, and then you do analytics on top of that. You use disease models, you use predictive models, et cetera, to provide recommendations and insights to the farmers. And that's fine. The thing is that you collect awfully a lot of data that you need to operate the farm efficiently. And then you can have a number of different packages configured for that. We have it in this way, other companies will have it in another way. But for all the different activities on the farm, you will need a slightly different set of sensors, slightly different types of machine learning models or some analytics, reporting, so that you can use that. And that is all fine for the farms. The thing is how you take all that data and make it available to the next one in the supply chain. Because as you can see, there's a lot of different sensors, a lot of different types of data. And it is useful and it is required for providing the service to that farm. But taking all that data and sharing it with everyone else is not feasible. Then there are privacy issues, then there are some commercial sensitivity issues. So you can't really do it. So you have to, and it's also, most of that data is not of interest to the next one in the supply chain, especially not to the consumer. Consumers, they want to see very simple view. Is it in line? Was this wine produced in line with all the regulation, or was this chicken grown as it was supposed to be, etc. All the same goes for the fish. So finding the way to compress, in a way, all this data that is collecting on different types of farms and make it available in a form that is understandable and easily usable by different players in the supply chain is a challenge. And then also making sure that not only that these other players in the supply chain can find the data that they are looking for, but they can also, to make it sure that they can trust the data and they can trace back the results that they are seeing with the raw data that were used to create those results. So these are the challenges. And in most of the supply chains today, you have this type of view. So the primary producer, they have their own system, the next one, the processing, the own next one, distribution, etc., etc. They all have their own IT systems, their own frameworks, their own systems, and they have a limited view of the whole, all the information that is available. And pushing information from one to another is really difficult. And the identity that the first one is using for a bottle of wine, it's lost when it's being pushed to a shop. And also comes with a fish. So whether it comes from this farm, that farm, it's very difficult to trace it all the way if you have this type of very isolated, or well, not isolated, but systems that do not have full connectivity and that are not capable of fully interacting. And this is where this whole thing with the blockchain is coming to is becoming interesting. So we work with the Origin Trail, our colleagues from Slovenia and Serbia. So they are building this decentralized knowledge graph, and they have built a protocol that is using the centralized knowledge graph that sits on a blockchain layer. The blockchain layer can be any blockchain in principle. At the moment, it's one of the bulk parachains are used. Previously, it was on Ethereum, but the protocol itself can sit on any of those. And this upper layer, this decentralized knowledge graph, allows us to create, out of the raw data, to create summarized data that is of interest to the processing or to the winery, to the transport, to the shops, to the retailers, and also use the mechanisms provided by this decentralized knowledge graph to enable search for the data, and then use blockchain to actually increase trust and trustworthiness of this, so that once we push this summary of data into the graph, it's also record made in the blockchain, so that the other stakeholders who are using that, searching for the data, finding data, using data in their own processes, can be assured that that data has not been changed, and that data can be traced back to the origins of how that summary was produced. So this is, we just recently finished the proof of concept of this, where we take the data from that is collected by our smart agriculture platform, AgroNet, and then based on that, we create not labels, something like this. We still don't have the graphical layout this nice, but this is for the tires in the EU. When you are buying tire, you get this on each new tire. So you can see the fuel efficiency, the braking efficiency, and also the noise that is that tire producing. And we are now creating a label similar to this for the farms, for the wines, for the poultry, for the fish. And this summarized information, it's easy to store in decentralized knowledge graph. You can also make that record on the blockchain. And the other players in the supply chain can easily understand it. And for those who really want to get more information, they need to understand, okay, why fuel efficiency is on A, or then they can trace it back to the actual raw data that was used to create these labels. The other point here is also that this decentralized knowledge graph, you can make some parts of this knowledge graph private, others public, so that you can still keep parts of your knowledge of the data not available to everyone, while you can share what you want to share, you can share and make it public, so that you have that distinction. It's not everything that you pushed in is just available to everyone, but you can make, you can control access to the data. So that's, I think that's the summary of what I wanted to say. So the point is that, yeah, there is a lot of need for the transparency. There is a big push from the EU. This is called Part2 strategy. There is a big push from the consumers who want to know more about where their food comes from, how it was produced, and finding ways to provide all that transparency in an efficient manner, which will not cause a lot of trouble for all the stakeholders to implement it, is something that a lot of projects are working on at the moment. And definitely, I would say that maybe, I'm not sure if not all, but probably more than 90% or almost all are looking into blockchain and looking into solutions like this decentralized knowledge graph to sit on top of blockchain to provide such transparency and trust in the data that is being produced. Thank you.
Thank you, Sajan, for that summary of a very complex project. A round of applause for Sajan. Thank you. I know it's tough now to give you a question. Maybe, how far now in putting together a pilot demonstration using blockchain for your project?
Sorry, I didn't, if it was a question for me, I didn't.
So I just wanted to know whether you have already finished pilots for blockchain for your project, or is it still too early?
You fish first?
A blockchain pilot?
Yeah, for the fish itself, the project started, as I said, 6 months ago. So it's still, discussion is mainly around understanding the context and understanding the challenges. What are the needs of the fish farming and the whole fish supply chain when it comes to transparency, among other things. And we are looking into using something similar as we use in Demeter. So this type of a blockchain at the bottom, and then things like that, decentralized knowledge graph, and then also combining that with the digital product passport that can give us a lot of information or keep information about the farm, about the fish, about all the different activities that are being done on farms.
Thank you very much, Sajan, for your contribution. I'd like to thank you for doing this. I would like to go to the next speaker. As a matter of fact, we are behind schedule for the lunch. So I have a great lady from the UAE with us. That's Dr. Huda Al-Khazaimi. I'm sorry if I misspell your name. She is director of the Center for Cybersecurity at the New York University in Abu Dhabi in the United Arab Emirates. She's going to talk about cybersecurity. So, Huda, can you share your screen?
Sure, but can someone please enable slide sharing?
That's a good one. So who is our genius? So maybe
it says that I cannot share my screen.
It's okay. Sir
Other
Jan,
participants are sharing.
I just want. Sir
So
Jan, can you please?
Can stop sharing?
Yeah. Sir Jan, can you please stop sharing your screen? Can we do it from here? Sir Jan, you are locking us. I think he ran for lunch. So we'll have to shut down the whole...
I'm still here, just trying to figure out how to do this.
So you look at the top screen at the top.
Yeah, but I don't know. Okay, right.
So click on at options at the top.
Yeah, I know, but...
You know these things, my friend. Okay, we're fine.
Okay. Yeah.
Thank you.
Sorry.
No, still.
Yes, so I'm just waiting for the current person to stop sharing.
Yeah.
Yes, that's perfect.
Good. So, Huda, welcome.
Thank you. Hi everyone, my name is Huda Al-Khazemi. I am from the United Arab Emirates. I lead a research group that's called EmirateSec, and that's focused on emerging technology and advanced research for cybersecurity, cryptology, and AI. I'm as well co-leading the Center for Cybersecurity in NYU Abu Dhabi. I founded that center. And we are here to conduct research, educate the public discourse, and shape and build the new technologies. Today, we are going to talk about the generic security implications for blockchain and what is the current landscape of security and trust and beyond when we speak about blockchain. I would like, of course, most of you know, and you're experts probably on blockchain, so you understand how does it work. Sorry. I think there's someone else in the room who is activating their mic.
Yeah. Just give him a second.
Yeah.
No, it's okay.
So we know very well that in a world of technology today, blockchain is gaining a massive impact. Since its creation in 1991, prior to the current understanding that it actually popped out at 2008 in one of the white papers, but there are traces about blockchain in the early cryptographic work of secure blocks that happened in 1991. Until today, in 2012 to 2023 as well, we're seeing this kind of evolution of blockchain for industrial applications like the one that we have seen in the prior slides. And their current role is very critical for the $3.2 trillion of investment in emerging technology. And they are at the moment making a market valuation of over I think anticipated $21 billion in 2025 in the global blockchain market, with actually the Asia Pacific, Europe, and North America leading these markets. But with that, we have also a sense of relief because blockchain don't come alone; they come together with all the other technologies that they push around. So when I want to address, for example, the security of blockchain, I have to address the security that comes across from all of the other emerging technology that are built upon the blockchain and other aspects. Last time I've talked in similar conference and congress for blockchain, I've faced a bit of a backlash when I say that in our lab, we actually attacked one model of blockchain, but I'm sorry, you will hear a lot of this today. And our current analysis, because we will go through the classical attacks that are available in a blockchain for blockchain technology, and as well the different attacks that we keep on seeing across board. And so, in reality of the matter, when you are embedding blockchain in the current technology, you have to understand the ramification of integration of these technology with the current landscape of, for example, metaverse or AI and other technologies that are pushed into the landscape. These technology, they don't come with 100% security maturity, so we are faced with the backlash of few security hiccups when we are analyzing actually for the security of this model. So yeah, it's a market that's growing, and we see the current global push for adoption of blockchain across board into different industry. We see the hype that's rising in the startup community as well, especially in the Middle East. When it comes to this, loads of countries are initiating their virtual assets authorities. We have VARA here in the UAE, but we also have many other virtual assets recognition units as the one that exists in the US. And today, when we are addressing actually the blockchain security, we shouldn't look at it as a technical problem. It should be as a holistic 360 evaluation of the problem. So we should look at the standardization, we should look at the trust models built around it, we should look at the energy consumption, because energy consumption dictates the footprint of algorithm that we're using, and it also dictates the security margin of these algorithms. If we are pushed in today's world to use a security margin that would run on a very restrained footprint for IoT environments, it means that we are sacrificing a little bit of the security on these environments. And if we are running it on energy harvesting devices, on edge computing devices, for example, it means as well we are sacrificing computational power that would also, in the design of whatever blockchain that we have chosen, which means we are sacrificing security end of the day. So we shouldn't just look at what the world is celebrating today, is the application of blockchain and the use of these blockchains and NFT structures and IoT structures and the different types of blockchain. But we should, when we analyze the landscape of security issues for blockchain, understand how that would impact the scalability of the algorithms provided, the interoperability of the connected systems, and how the energy consumption is going to affect this as well as if we have good technical resources who would implement these platforms, because sometimes the security breaches doesn't come from they do come from a very well developed technical platforms, because the security measures are not being taken seriously. So again, when we addressing the security aspects, it's not just addressing encryption or authentication models that are being used on the blockchain, or the tokenization, decentralization protocols, or the distribution protocol, but all of this collectively and making sure that they are secure for the mass. We, on the lab, when we look at the security of the blockchain from a technical perspective, we try to revisit it from the perspective of cryptographic aspects, like how relevant is it to use our lightweight cryptographic algorithms on private keys in order, or our lightweight hashing algorithm for a specific blockchain, and will certain protocol attacks still survive or not? I'm not gonna go through this, but it's also, we try to identify the different security controls that we can apply on identity level, on the authentication level, on the authorization level, and web security for the presentation layer of the network security, and as well on the application layer. We try to work on smart contract security and blockchain protocol security and data motion. Data motion security is critically important when blockchain is applied for mobility solutions, like for self-driving cars, for example. And this is, we have managed to build, since last time I've met you, another adversarial model, learning model that we have applied using AI techniques to attack a data motion that we have applied on self-driving cars in order to have a denial of service attacks that are happening on these edge computing devices. And then what manifested at the end is the lack of availability of these resources on a wider sense. So when you look at the attack sphere of blockchain, we have the peer-to-peer network attacks, the smart contract-based attack, the wallet-based attacks, and the ledger-based attacks. And most of them in reality are aiming for protocol-level attacks that would establish resource exhaustion in 100%. I'm sure most of you know the 51% attack, which is an attack that aims to use or abuse a group of miners who can control more than 50% of the network mining or hashing rate. And thus, this will deduce an interruption of the different blocks computation that are happening on the network. We know that despite the fact that it has been an attack that rose quite well in the 2017, we still see it today in certain very basic networks level. We as well see civil attacks still happening on few network structures that are obsolete and that are not updated, where malicious attacker will be able to create as many as possible. Sorry for this, but I have a bit of lag on my slide. I don't know if you can see this. Just 1 minute. They can create as many as possible fake identities to affect the overall network performance and initiate, again, a denial of service attack. Again, we are using in our attacks machine learning techniques in order to combine, I'm going to go faster on this, combine the attack performance level in order to, sorry for this, I'm gonna just, for this. So in order to build adversarial learning for self-driving cars. So what we've done in the beginning of this implementation is that we distributed the different data that exist on this self-driving car models on edge computing platform that are available on the driving units using and secured it using a blockchain kind of technology. And then we attack this technology. In the former example that I presented, it was without blockchain technology, and we have analyzed the efficiency and performance of this attack. And when we applied it after implementing one of the blockchain's implementation, we realized that this attack that we call 1 pixel attack, actually, because we change 1 pixel at a time, to change the perception of the signage that are being captured by the self-driving car on the computational units. Actually, the attack worked in 30% performance, in comparison to the natural attack, to the other classical attack. Again, as well, we realize that most of these blockchains today, they're being used on ledger networks for IoT network. And regardless of the fact that on 7th of March, we had an announcement that we have a perfect candidate by Nest for one of the IoT ciphers, we still see people using a very outdated encryption, reduced encryption algorithms that we have been able to attack in the lab with reduced security, not with full deduction on the cipher, but with reduced security. And we have been able to trace a little bit of the activities that are happening on the IoT assets. In addition to this, we have tried to use fully homomorphic encryption in conjunction as well with the blockchain technologies in order to provide security in between the cloud services and the edge computing units. And also in order to provide the security required when you are pushing for attempts of computing partial data computing partial encrypted data on the cloud. What we have noticed is that, of course, there's a huge level of performance issues when you are applying this level of homomorphic encryptions because it is very taxing on the blockchain network, on the other activities that are existing within the mining algorithms as well and verification algorithms. And that's primarily of the double effect of the necessity of improved efficiency when it comes to homomorphic encryption on specific hardware, especially on specific cloud networks. So we have faced issues applying for fully homomorphic encryptions, for example, but we've been very lucky when we applied somewhat homomorphic encryption because we chose a single operation kind of technique on the security of the addition. And we're still having issues on the fact that certain fully homomorphic encryption algorithms are not fully standardized, so we can't use them on the wider network of IoT because we need to still do more effort into this. So when we try to combine the application of homomorphic encryption and AI with the blockchain that we have implemented, we faced issues on, for example, secure outsourcing, allowing untrusted third parties to be able to compute certain level of data. And that was necessary for us to open gateway for because we have other nodes on the blockchain network that needs to do computations on the network. So we had an issue with that in terms of security and in terms as well on performance reductions. We had issue with the flexibility of encrypted data usage, and we needed to improve the transparency that's being provided in addition to privacy aspects. So at the moment we are combining one of the applications that we are using in the lab with federated learning and homomorphic encryption on blockchain environments in order to improve our parameter selections and to as well develop better hardware designs for fully homomorphic encryptions and also for lightweight blockchain development in the lab, so we can speed up the operations that are required to compute the encryptions and the authentication as well as the hashing and a very lightweight kind of aspects with a lower energy prints, which would allow us to bring better cryptographic primitives to be used on the blockchain environment. So that's the massive work that we are doing at the moment in the lab on the technicalities of attacking specific and improving the security of specific blockchain architectures. And it's not just a work of understanding and improving a specific level of technology or an algorithm or a protocol. It's actually a systematic effort that requires cross-border collaboration as well, multi-stakeholder collaboration in order to have open R&Ds in between what we do in academia, what happens in industrial labs, and what happens as well in open research communities for us to develop the new algorithms that are going to change the security status quo for these technologies and for technologies that are being used on blockchain environment. Thank you so much. These are my contacts. If you have any questions, I'll be more than happy to have them. Unfortunately, I was slotted a bit earlier than this time slot, and I did not schedule myself very well, so I'm in back-to-back meetings. So I will have a meeting. I'm actually in the meeting room with people coming in for my next meeting so I will be starting maybe in 2-3 minutes. So I have 2-3 minutes for questions, but if I don't get time to connect with you, please feel free to WhatsApp me, email me on these contacts available online.
Thank you, Huda.
Thank you.
Thank you for that brilliant presentation. As a matter of fact, you confirm the recent study back in June to the White House on blockchain, on crypto over blockchain that are using old software and not updated, and they're centralized and so on and so forth. So there is a lot of work to be done in this area. I don't think we have time for questions this time because we are already eating the lunch time as well. So
sorry. Bon appetit and enjoy Morocco and enjoy Casablanca. They have the best food.
Excellent.
Thank you.
I know you speak French
Thank
too.
you so much.
Merci.
Thank you so much.
À la prochaine.
Yeah, I think Mariam Ayash, she wanted to ask a question. She sent me a question. She sent me a message.
Okay. Thank you so much. I don't know if we have time to ask questions. Do we?
Yeah, go ahead, Mariam. Go ahead. Maybe maybe 30 seconds.
Yeah, I will be so fast. Thank you so much, Dr. Huda, and I'm happy to see you again after the 6 years I met you in your university, like 6 years ago. I just have one question. Based on what you have been doing on research lately, what is the layer which is more vulnerable in the blockchain technology? Is it the peer-to-peer or the smart contract or the ledger? What do you think? Which part is more vulnerable and need to have more research on that?
I think a very good question, Mariam. I think with the evolution of emerging technology today and the introduction of alternative computing, we have today discussions around, deploying quantum computing, deploying as well accelerated computing platform, accelerated edge computing platform, and in-memory based computational platform to improve performances margin for IoT platforms, and then use blockchain on top of that. With that comes the risk, not on all of these layers, because of the fundamental issues that we have with the cryptographic primitives, that are delivering for all of these layers. We need to fix the security margins of these primitives, because if we don't do that, then we are going to live in a world that gives the possibility to attackers to attack systems in a matter of seconds rather than years when it comes to attacking encryptions and hash functions that are being deployed at the moment on different structures. So we need, the biggest struggle, in my opinion, would be building better cryptographic primitives for restricted, limited environments. And I'm talking about energy harvesting environments. I'm talking about guaranteeing 2 to the power 215 security in a parameter or in an environment that is on the basis of energy harvesting environment, for example, where a fluctuation of 1 degree of temperature is not possible and computations in memory on these devices are not possible. So that kind of a match for the fundamental primitives are very important.
Thank you.
Thank you so much for the question.
Thank you very much.
Thank you. All the best for everybody. Thank you.
Thank you very much, Huda. Thank you very much. Next time, inshallah, in Morocco. We invite you in Morocco, inshallah, in person.
Inshallah.
Okay.
Inshallah.
Thank you very much. Thank you
so
for your coming. Now we go to lunch. It's upstairs for the. We come back at 2:15. To 15 minutes. Yeah. Okay. Thank you very much.
Record.